Good morning, students. So the previous class we have derived the formula to find the parametric, non-parametric vector equation of the straight line and Cartesian equation of the straight line. So using the formula we are going to discuss exercise 6.4 first problem. Find the non-parametric form of vector equation and Cartesian equations of the straight line passing through the point with the position vector 4i cap plus 3j cap minus 7k cap and parallel to the vector 2i cap minus 6j cap plus 7k cap. Okay, so see what is given. The straight line passing through the point with the position vector, that is one passing point whose position vector is given, okay, and the straight line parallel to the vector. So in this problem one passing point and one parallel vector are given. So see that yesterday class, so we have discussed, you see the condition, one passing point and one parallel vector. So the passing point is taken as A, whose position vector is A vector, and the parallel vector is taken as B vector. So the parametric equation is this. This is the non-parametric equation, and here you will have the Cartesian equation. Okay, here in your problem what is asked? Non-parametric form of vector equation. They didn't ask the parametric form. They asked only the non-parametric form. So first from the problem, so this is the position vector of the passing point. Okay, so it has to be taken as A vector, and this is the parallel vector, so it has to be taken as B vector. So what is the formula? Non-parametric formula is R vector minus A vector cross B vector is equal to 0 vector. You should know the formula. So we have to write the formula first. So R vector minus A vector cross B vector is equal to 0 vector. So R vector is written as it is minus what we have taken as A vector. So this is your A vector. You have to substitute. So cross B vector, in the place of B vector you have to substitute 2i cap minus 6j cap plus 7k cap is equal to 0 vector. So write the formula and substitute A vector and B vector. Here A vector is what? It's a position vector of the passing point. What is your B vector? B vector is the parallel vector to the straight line. Now what is the second one is asked? Cartesian equation. So come to the Cartesian equation. So the formula is x minus x1 by b1 is equal to y minus y1 by b2 is equal to z minus z1 by b3. Now what is needed? x1, y1, z1. They are nothing but the passing point of the straight line. What is b1, b2, b3? They are the direction ratios of the given line. Okay, so here, so the formula is written. So x1, y1, z1 has to be taken from the passing point. Here the position vector is given. So therefore the passing point is 4, 3, minus 7. So x1, y1, z1 can be written as 4, 3, minus 7. Next you have to consider b1, b2, b3. What they are? They are the direction ratios of the given line. They are proportional to the parallel vector ratio. So what is it? 2, minus 6, 7. So your b1, b2, b3 is nothing but 2, minus 6, 7. So you have to substitute these two results in the Cartesian equation. So see that x minus, what is your x1? 4 divided by b1. What is b1? 2. So the first result, so it is x minus 4 by 2 is equal to y minus y1. What is your y1? It is 3. What is your B2? That is minus 6. So y minus 3 by minus 6. which is equal to z minus, z1 is what? Minus 7. So z minus of minus 7. So it will become z plus 7 divided by this 7. So this is the Cartesian equation. So we'll come to the second problem. Find the parametric form of the vector and Cartesian equations of the straight line passing through the point minus 2, 3, 4 and parallel to the straight line. Okay, so see now here what is given? The straight line passing through the point. So passing point is given, one passing point, and parallel to another straight line. Okay, parallel to another straight line. From this straight line, your required line and the given line are parallel. So we can take the direction ratios of the required line from this. Okay, so first over here what is given? One passing point and one parallel vector. Again, what is the formula? Here what is asked in this problem? Parametric form. So the parametric form is nothing but r vector is equal to a vector plus tb vector. So what is a vector? It's a position vector of the passing point. What is b vector? So b vector is the parallel vector. Okay, we'll see now. So here in this problem the passing point is given. So your a vector is equal to what it is? Minus 2i cap plus 3j cap plus 4k cap. Okay, and we have to find the b vector. How the b vector should be? So it is parallel to the line. But it is not given directly. What is given? Parallel to another straight line is given. So your required line and this given line are parallel. So you consider this line in the correct format. You see that x minus 1 by minus 4 is equal to y plus 3 by 5. Here you have to bring z should be positive. Z should come in the front. Okay, so from this term you have to take minus out. Okay, z should be positive. X, y, z should be positive. So you have to bring this, you have to take minus out from these two terms. If you take minus out, it will become z minus 8. So in the front minus you have to give to the denominator. So the given line can be written as x minus 1 by minus 4, which is equal to y plus 3 by 5 is equal to z minus 8 by minus 6. Okay, so we have to bring the standard form of the line. Okay, so what is the direction ratios of this given line? That is minus 4, 5, minus 6. And how is your required line? Your required line is parallel to this given line. So both the direction ratios are proportional. So therefore the direction ratios of the required line are it is minus 4, 5, minus 6. It is denoted by b1, b2, b3. So here you are having a vector. So we can write from this b vector. So what is your b vector? B vector is equal to minus 4i cap plus 5j cap minus 6k cap. So now you are having a vector and b vector. That is the position vector of the passing point and the parallel vector. So here what is asked? The parametric form of vector equation. So what is the formula? R vector is equal to a vector plus tb vector. T belongs to R. So you have to substitute in the place of a vector as minus 2i cap plus 3j cap plus 4k cap. So it is substituted here. Plus t into what is your b vector? So minus 4i cap plus 5j cap minus 6k cap. So this is the parametric vector equation of the required line. Next one, what is asked? Cartesian equation of the straight line. So Cartesian equation of the straight line formula is x minus x1 by b1 is equal to y minus y1 by b2 is equal to z minus z1 by b3. x1, y1, z1 is the passing point. Here in your problem, what is the passing point is given? So it is minus 2, 3, 4. So x1, y1, z1 is minus 2, 3, 4. And what is your b1, b2, b3? They are the direction ratios. Okay, what is it? Minus 4, 5, minus 6. So we have taken, so we have to substitute in this formula. So here it will be x minus, what is x1? Minus 2. So x minus of minus 2, that is x plus 2. Divided by, what is b1? It is minus 4, which is equal to y minus, y1 is what? 3 divided by 5. So which is equal to z minus z1. Z1 is what? 4 divided by minus 6. So this is the required equation. So see, come to the third problem. Find the points where the straight line passes through 6, 7, 4 and 8, 4, 9, cuts the xz and yz planes. Okay, so now the straight line passes through 2 points. So here we have to consider the equation. 2 passing points are given. This is the parametric equation, non-parametric equation and the Cartesian equation. So for this problem, so Cartesian equation is convenient to do the calculation. So we are going to consider the Cartesian equation. So what it is? 2 passing points are given. The Cartesian equation is x minus x1 by x2 minus x1, which is equal to y minus y1 by y2 minus y1 is equal to z minus z1 by z2 minus z1. Okay, come to now. So the first point is taken as x1, y1, z1 and the second point is taken as x2, y2, z2. So first we are going to write the Cartesian equation. So take this is x1, y1, z1. So the equation will become x minus 6 divided by 8 minus 6, x2 minus x1. Next, y minus 7 divided by 4 minus 7 is equal to z minus 4 divided by 9 minus 4. Or otherwise, if you consider this point as x1, y1, z1 and this is x2, y2, z2, you will get this form. Either any one can be found. Okay, so while you are calculating, here you will have 8 minus 6 is 2. Here you will have 4 minus 7 is minus 3. 9 minus 4 is 5. So here the passing point is, second point is x1, y1, z1. You will get this answer. Okay. So see now you are going to find an arbitrary point on the straight line. Okay, how it will be. So for that you have to take the whole equation is equal to t. Okay. Take the first term, x minus 6 by 2 is equal to t. Okay, so this 2 when you take it to the right side it is 2t. This minus 6 when you take it to the right side it is plus 6. So what is your x? X is equal to 2t plus 6. Okay, I'll explain the whole term, all the 3 terms which is equal to t. Okay, so now you are going to find x, y, z. So take the first term alone. What is it? X minus 6 by 2 is equal to t. So x minus 6 is equal to 2t. 2 into t. Next x is equal to 2t plus 6. So x value is 2t plus 6. In the same way, y minus 7 by minus 3 is equal to t. So y is equal to minus 3t plus 7. Next, z minus 4 by 5 is equal to t. So z is equal to 5t plus 4. In the same way, the 3 terms of the next one is equal to s. So another parameter, it is equal to s. So from that you have to find out what is x, what is y and what is z. You consider the first term, x minus 8 by minus 2 is equal to s means x minus 8 is equal to minus 2x. x is equal to minus 2x plus 8. In the same way, you have to find the points on this straight line. Okay, so here now what is given? The straight line cuts the xy, first one xz and yz plane. So first you consider the xz plane. What is given? That the line cuts xz plane. So xz plane means the point of intersection. When the point of intersection of the line and this plane whose y coordinate is 0, because the straight line cuts which plane? xz. So in the point of intersection the y coordinate is 0. So see the y coordinate, this is the point. So what is the y coordinate? Here you will have minus 3t plus 7. So minus 3t plus 7 is equal to 0. So you will get what? T is equal to 7 by 3. So minus 3t is equal to minus 7. So minus minus getting cancelled. 3t is equal to 7. T is equal to 7 by 3. So here also if you consider this point, the y coordinate will become 0. So 3s plus 4 is equal to 0. S is equal to minus 4 by 3. Either any one can be taken. So after finding t, okay, it has to be substituted in this point. Okay, so when t is equal to 7 by 3, what will come? You see that 2 into 7 by 3 plus 6. Here minus 3 into 7 by 3 plus 7. 5 into 7 by 3 plus 4. Okay, so here it will be 2 4s or 2 7s or 14. 14 by 3 plus 6. So when you take LCM, here it is 18. 18 plus 14 is 32 by 3. And plus here 3 getting cancelled. So it is minus 7 plus 7, that is 0. So when you multiply these two, so it is 35 by 3 plus 4. So when you take LCM, it is 12. So LCM is 3. So when you multiply, it is 12. 35 plus 12 is 47 by 3. So this is the point at which the straight line cuts the xz plane. In the same way, so here I have substitute t value. So you can consider s value. S value has to be substituted in this form. Okay, so you will get the same point. Okay, so the first subdivision here xz plane we have completed. So next we have to find the point at which the straight line cuts the yz plane. So what is the plane? Yz plane. So yz plane means x coordinate will become 0. Go for the x coordinate. What is the x coordinate here? 2t plus 6, that is equal to 0, or minus 2s plus 8 is equal to 0. So when you equate to 0, your t value is equal to minus 3 and s is equal to 4. Either you can take t or s and substitute in the corresponding points. So here in this second subdivision, I have taken s is equal to 4. It has to be substituted in this point. So what s is 4? So minus 2 into 4. Minus 2 into 4 plus 8, comma, 3 into 4 plus 4, comma, minus 5 into 4 plus 9. Minus 5 into 4 plus 9. So here minus 8 plus 8 is 0 and 3 into 4 is 12. 12 plus 4 is 16. Minus 5 into 4 is minus 20. Minus 20 plus 9 is minus 11. So this is the point at which the straight line cuts the